Determine the equation of the least squares regression line for the data. So let's take a look and see what's happening. So we have the weight of 15 players, right, of a rugby team. And then we have the number of push-ups per minute that they can do. 1.1, determine the equation of the least squares regression line for the data. So the weight is our x, right? And then the number of push-ups that a person can do in a minute is our y. Well, we don't even have to guess that or find a way to reach that conclusion ourselves. It is given, right? Weight, and then in brackets we have x, and then the number of push-ups we have y. So we want to find the equation of the least squares regression line. So that is to say, we are looking for y is equals to a plus bx. We are going to use our calculator in order to do this. So let me show you how we do that. We want to go to our calculator, press mode setup, and then we want to press 3, right? Because that's the option for stat. So after you press 3, then you press option 2, which says a plus bx. In a different calculator, it can be a different option, but we wanted the number that has a plus bx. Press that number, and then we can enter our x values. So you can see the data that we have 34, followed by 32, 40, 27. You have to be very careful when you enter your data, because if you make one mistake, all the answers are going to be incorrect if you make one mistake. So you have to be very careful when you enter this data. After 27, we have 55, and then is that 39? Yes, 39. 44, followed by 30, 57, 28, 32, and 31. Right, so those are our 15 entries as far as the x values are concerned. So now we need to go up there and enter the corresponding y values, right? So we have 26, 21, followed by 6, and then we have 20, 16, followed by 26, 33, 23, not 33. You see there, almost made a mistake, and all my answers were going to be incorrect. So 28 goes with 26, 27 goes with 23. Okay, and then 55 goes with 7. And then we have 18, 14, 17, 8, 28, and lastly, not lastly, but second last, 25, and lastly we have 20. So we've entered our data, right? I press equals to, and then after that I can press AC, right? And then I press shift 1, and then I press 5, right? That REG, I think it stands for regression. And then when we press 5, we have our variables. You can see we have A, we have B, right? So when I press 1, in order to access the value of A, and then press equals to, and then that is 39.46. So A is equals to 39.46. What about B? So I press AC, shift 1, 5 for regression, and then B. So I press 2, and that is minus 0.59. So that's the value of A, that's the value of B. So Y is equals to 39.46 minus 0.59x, right? So that is the first question, 1.1 out of 3 marks. And then 1.2, we're looking for the correlation coefficient. So that is R, right? So we've already entered our data. We just press AC, shift 1, 5, and then you can see that R is option 3 there. And then when I press equals to, I get minus 0.7979. So minus 0.8. That is the correlation coefficient. And then 1.4, write down the mean number of push-ups for the given data. The mean number of push-ups for the given data. So the number of push-ups is our y, right? Let's see if we can find that when we press shift 1. So shift 1, and then let me hit 5 and see what happens. We have X and Y there. Yeah, I think that is Y bar. Let's see. 5 is equals to, oh, okay. Did I just get error? Okay, so I don't know whether that is supposed to give us the mean or what, but just to be safe, let's just press shift 9, clear everything, you know, exit stats, and then just calculate the average manually. So we want the mean number of push-ups. So the mean number of push-ups, so our Y bar is going to be equals to. So now we need to enter all those numbers on Y, right? So 26 plus 21, plus 21 plus 6 plus 20 plus 16 plus 26 plus 23 plus 7 plus 18 plus 14 plus 17, and then we have 8, 28, 25 plus 20, and then we divide that with 15, right? Because we know that we're talking about 15 players here, and then that is 18.3 recurring. So the mean number of push-ups for the given data is 18.33. That is 1.4. Right. Does it make sense to be 18.33? It makes sense. The highest number is 28. Most numbers are below 20. So a mean of 18.3 makes sense. Okay. And then 1.6, or not 1.6, but 1.5. The players trained hard during the season. Well, you would like to assume. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the last season. How does the increase in the number of push-ups influence the standard deviation of the data? This is just theory, essentially, right? This question does not have anything to do with the question we have at hand. It's just testing to see if you know the theory. So if all the numbers, all the data points increase but the same value, it's not going to affect the standard deviation. The standard deviation is still going to be the same. They're going to deviate from each other by the same number because they've all increased in the same fashion. If it was a decrease, they would have all decreased in the same fashion. So there's no difference in the standard deviation. So yeah, standard deviation remains the same. And then 1.6, I want you to let me know in the comments. At the beginning of the season, the coach used the least squares regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Right, so that is for 2 marks. Let me know in the comments, how do you approach this question? 1.6, there we go. Let's calculate the gradient of DC. The best thing to do in this case is to choose which point between C and D we are taking as 0.2 and which point we are taking as 0.1. So if we take point C as 0.1, we're going to have x1, y1. And then if we take D as our second point, we're going to have x2, y2. But whatever point you take as 0.1, 0.2, it really doesn't matter. We should get to the same answer ultimately. So let's go ahead and do that. The gradient of DC will be equals to y2 minus y1, everything divided by x2 minus x1. Sticking to the basics, right? So in our case, y2 is going to be minus 9 minus y1, which is 0. Everything divided by x2, which is 3, minus x1, which is minus 9. So this is equals to minus 9 divided by plus 12, right? And then if you put this in your calculator, or if you simply divide the numerator and the denominator by 3, you should get minus 3 divided by 4. So this right here is the gradient of DC. Sticking to the basics, nothing complicated really. And then the second question, 3.2, determine the equation of DC. So we're looking for the equation of DC in the form y is equals to mx plus c. Another question that is very basic, right? No complications. We're just sticking to the basics here. We have 2 points C and D. We want to find the equation. So there shouldn't be no way to run this question for ourselves. It's really straightforward. Doesn't require us to come up with any creativity whatsoever. But anyway, stories. Let's take a look. 3.2. So the gradient, we already know that it is minus 3 over 4 x plus c, right? And then we can substitute D, we can substitute C, and then find C, right? C, I mean the constant, and we will have our equation. So if we substitute C, I want to substitute C because I have 0 there and it is going to make my life simple. C has coordinates minus 9 and 0. So when we substitute it here, we're going to have the y value is 0, minus 3 over 4, x is minus 9, plus c. So we have 0 being equals to minus 3 multiplied by minus 9, that is plus 27, 9, 18, 27, right? Divided by 4 plus c. Should be easy to see that c is equals to minus 27 over 4. So what is y? Y is equals to minus 3 over 4x minus 27 over 4. There we go. We have the equation of DC. Sticking to the basics. Let's take a look at 3.3. So in 3.3, we're supposed to show that k is equals to minus 6. K is the y value at B, right? Is the y value at B. And B is a point that lies on the line CD. So we already have the equation. We know that B has coordinates minus 1 and k. If we substitute this in our equation, in place of y, we put k. And then in place of x, we substitute minus 1. And then minus 27 over 4. So k is equals to minus 3 multiplied by minus 1. That will be 3. So 3 over 4 minus 27 over 4. And then this is just a minus 24 over 4. 6, 12, 18, 24. So this is equals to minus 6. So there we go. Just like we're supposed to show. K is indeed equals to minus 6. What about 3.4? Calculate the length of DC. So if you take a look at this question, 3.1, 3.2 up to 3.4, there's really no creativity. We are just sticking to the basics, right? So in order to find DC, well, we have the distance formula being y2 minus y1 squared plus x2 minus x1 squared. But I'm going to take a shortcut here, if you allow me to do that. So take a look at this. Y2 minus y1. We already have that when we were calculating the gradient, right? Y2 minus y1 is minus 9. So here I have minus 9 squared plus x2 minus x1 is plus 12. So I have plus 12 squared. So now you just put that in your calculator and DC is equals to 15 units, right? And then 3.5, calculate the ratio of dB over DC. Ratio of dB over DC. dB is a length, right? And the DC is also a length. Okay, so how can we solve this question? The problem that we have here is that we don't have the coordinates of B. That is a problem. Oh, well, at this point we do, because we have the value of k. We know fully well that it is minus 6. So we have the value of k. So option 1. Option 1 is to calculate the length of dB, right? Because we already have the length of DC. DC is equals to 15 units. So we can just calculate the length of dB and then we find the ratio of the two. We say dB over DC. And then there's another option. We can just rotate this. Oh, okay, I can't rotate this. I wanted to rotate the diagram here. But then if you rotate this diagram, this can be a straight line if you rotate it, right? Anti-clockwise. And then you just find the distance from C to B and the distance from B to D. But let's just calculate the length of DB. It's fine. So the length of DB, therefore, will be equals to y2. Let's take D as our second point. So we're going to have minus 9 minus 6, because k is minus 6, right? So that is plus 6 squared, plus x2 3 plus 1 squared. Okay, so if you put this in your calculator, I mean, we have minus 9 plus 6, that is going to give us 3, and then 3 plus 1 is 4. So we have a triangle here. One side is 3, another is 4. The hypotenuse will be 5. So dB is 5 units. So dB over dC is equals to, what is dB? dB is 5, dC is 15. So this is equals to 1 over 3. So there we go. Right. I do realize that there are other ways we can use to solve this question, but if you get to 1 over 3 and then you didn't break any rule, you should probably be fine. And then that is 3.5. Let's take a look at 3.6. So 3.6, it's out of 4 marks, but for some reason I did take more time thinking about 3.6 as compared to 3.7. I didn't take much time with 3.7 because we need to do a lot of things, but it is a very basic equation. We have seen such questions before. The problem was with 3.6. Maybe it has been there before, but I don't remember solving 3.6, so I had to really think. So let's take a look and see what is happening. If M is a point on AD, okay, so let me just erase some of this junk. M is a point on AD such that AC is parallel to MB. Calculate the ratio of the area of MBD divided by the area of ACD. So, okay, we need some point on AD such that AD and MB are parallel to each other. So, you can see that I'm using a ruler here. So, I just need to go down until I touch a point B. And then I will draw a line and put M. So, there we go. I just need to put a line here. And here I have my coordinate M. So, yeah, M is such that CAC and MB are parallel to each other. So there we go. I have M. But I want the area of this true triangle, MBD. So area of MBD, triangle MBD. So let's go ahead and take a look at triangle MBD. Let's just highlight triangle MBD, right? It's the smaller one. This is MBD. Let me change the color and take a look at the other triangle. The other triangle that we're interested in is triangle ACD. So ACD, right? We have two triangles here, and then MB is parallel to AC, and we want to find the ratio of the triangles. One thing that I realized is that, okay, in 3.5, I found the ratio of DB over DC. So I assume that is essential in 3.6. I might need to use that, right? So let's just keep it in mind that DB over DC is equals to 1 over 3. But we cannot calculate the area with just one side, right? We cannot calculate the area with just one side. We need two sides and the angle that they sandwich. Okay, but take a look at this. Let me show you something. I realized not fairly quick after some time. Not fairly quick. It was not quick. It took some time. So I realized that this true triangle, what is this point again? This is point D. This is point D. These two triangles are similar to each other. That's what I ended up realizing. Let me prove the similarity. First of all, in these two triangles, triangle AMBD and triangle ACD, you will realize that angle D is equals to angle D, right? That is just a common angle. This angle right here is just a common angle. Apart from that, you will realize that this angle here, right, angle MBD should be equals to angle ACD, right? Angle MBD should be equals to angle ACD. They should be equals to each other because the two lines AC is parallel to MB. So the two angles should be equal to each other. So we have proved that two pairs of angles are equal to each other. Of course, the third angle is going to be equal. So now we know that triangle MBD is similar to triangle ACD, right? Now we know that. But why is it essential for us to prove similarity? We want to prove similarity so that we can use proportions. We want to prove similarity so that we can use proportions, right? Proving similarity is the only thing that will allow us to use proportions here as far as this question is concerned. So let me show you what we are going to do. Therefore, we can say that we already know from the question above, right, that dB, well, what am I saying? That dB over dC is equals to 1 over 3, right? We already know that, but now we can play around with the other sides. Okay, so what can we say? We can say that, oh, okay, dB over dC, right, should be equals to, let's pick any other side. It is equals to, we can say dB over dC is equals to dm over dA, right? The other side, because we said that these divided by these, but now because we know that the two triangles are similar, we can now say these divided by this should also be equals to the ratio of the other sides. So this should also be equals to 1 over 3, right? And why are we saying that? Because the two triangles are similar. MBD is similar to triangle ACD. So we've proved that the two triangles are similar and that all the sides will be in proportion, therefore. But why are we doing that? Let me show you. We can say that the area of triangle MBD, the smaller triangle, right, is equals to half dB multiplied by dm, and then we say sine of angle D, right? Because angle D is the side, is the angle that those two sides sandwich. And then as far as the area of triangle ADC is concerned, we can say half, and then we use DC and DA, right? And then we take sine of the same angle because well, it is the same angle that is sandwiched by those two sides. So now we can proceed to the ratio and say that the area of triangle MBD over the area of triangle ADC is equals to a half dB dm sine of angle D, everything divided by a half DC dA sine of angle D, right? So take a look at this. A half and a half cancels out, sine of angle D and sine of angle D cancels out. We are left with dB over DC multiplied by dm over dA. dB over DC, dB over DC. What is dB over DC? We know that dB is 1, right? 1 unit, and then DC, yeah. So from D to B, we know that it is 5 units, and then from D to C, let's take a look once more. Let me make sure that I'm not making any mistake here. From D to C, is it 3 units? From D to C, we had 15 here from D to C, and then from D to B we had 1, right? So okay, everything is fine. So DB, we have 1 there, and then DC we have 3, multiplied by DM. DM, same thing, right? 1 over 3. So we are going to have 1 multiplied by 1, which is 1, 3 multiplied by 3, which is 9. So the ratio of the area of the two triangles is 1 over 9. So there we go. That is 3.7. And then 3.6 I meant. 3.7, it is further given that the gradient of AD is minus 4. So the gradient of AD is minus 4. And the length of AD is 612 units. So the length of AD is 612 units. So we can say that y, right, being the equation of AD is equals to minus 4x plus c. So let's take a look at AD. We do have the coordinates of D, which happen to be 3 and minus 9. Okay, so we can substitute this here, right, where y is minus 9 and then minus 4 multiplied by 3 plus c. So minus 9 is equals to minus 12 plus c. So 3 is equals to c. Okay, so we have y being equals to minus 4x plus 3 as the equation of the line AD. Okay, but we are looking for the coordinates of A. So now that we have the equation of AD, we can say that instead of having the coordinates of A as some x and y, we can say that A is x, but x being x, y should be minus 4x plus 3. This should not be groundbreaking. Should have come across something like this at some point of time. So those are the coordinates of A. Let's now use the other piece of information that we have to actually find the coordinates of A, because now we have the coordinates of A in terms of x and y, right? But we can use this distance to actually find the coordinates of A. So we can say that AD is equals to the square root of x2 minus x1. So let's take D as our second point. X2 is going to be 3. So we have 3 minus x squared, right? And then plus y2. Y2 is minus 9. So we have minus 9 minus 4x plus 3. So that is going to be plus 4x minus 3. Okay, so AD is equals to the square root of, let's not forget that we have AD. AD is square root of 612. So square root of 612. So we have 3 minus x squared, right? And then here we have plus minus 9 minus 3. Minus 9 minus 3, that is minus 12. So we have 4x minus 12 squared. So what do we want to do? We want to square both sides. So let's go ahead and do that. If we square both sides, we're going to get 612, right? And then we get rid of that square root, and then we just solve what's inside the brackets there. So when we solve that, minus x multiplied by minus x is x squared, and then we have minus 6x plus 9. That is that first part. And then the second part, seems like I need my calculator now. We have 4x multiplied by 4x, that is 16x squared. And then minus 12 multiplied by 4, that is minus 12 minus 24 minus 48, and we multiply that by 2, minus 96. So we have minus 96x and then plus 144. So 612 is equals to x squared minus 6x minus 96x. Oh, well, we have 16 here. It's 16 there. So let's write that as 17x squared and add those two. And then minus 6x minus 96x. So 96 plus 6, that is 102. So we have minus 102x. And then 9 plus 144. So 144 plus 10 is 154. So that is 153. So we have plus 153. And then we take 612 to the other side. Okay, so 17x squared minus 102x plus 153. I'm going to take my calculator. Clearly, I underestimated the problem. So we have 553 minus 612, which is minus 459, being equals to 0. So let me see if I can divide all these terms by 17. 459 divided by 17. Yeah, 17 is a factor of all these terms. So we have x squared 102 divided by 17 minus 6x 459 divided by 17 minus 27 being equals to 0. Factors of 27, 9, 18, 27, 9 and 3. Okay, so x plus 9, no, minus 9 multiplied by x plus 3. I think this works. Yes, so x is equals to 9, or x is equals to minus 3. But I like minus 3 because a is in the second quadrant, so its x value must be negative, right? So now that I have x, let me substitute it into minus 4x plus c. What is c? C is 3. Okay, so this should give us 15. So the coordinates of x is minus 3, y is 15. There we go. Tell me, which video should we do next? Here we go. Let's take a look at 4.1. Write down the coordinates of L. So I do have a few issues with this question. I'm about to show you why in a second. So let's take a look at the equation statement. In the diagram, M is the center of the circle. The center cuts the x-axis at N. Easy to see on the diagram. ST is a tangent to the circle at P. Easy to see also. We have the point R and then L lie on circle. O and V are the x-intercepts of PL. O and V. Okay, O and V are the x-intercepts of PL and RL respectively. Okay, I was a bit surprised, but there we go. That is the information we have. And we are supposed to somehow write down the coordinates of L. So the assumption here, only possible solution to this question is to assume that PL is a straight line. That is the only way we can be able to find the coordinates of L, which is not given, right? It is not said that PL is a diameter, or it's not said that PM and L are collinear. They do look like they form a straight line, but it is not said. So I have a problem with that, because since when do we just assume? We don't have that information, but we're expected to assume, right? I did say the same thing about equation in mathematics paper 1, that we were supposed to make an assumption that A is an x-intercept, while it is not told. Why it is not, there's no hint to suggest that it is, right? So let's go ahead and find the coordinates of L. But I don't like the equation, because we have to assume that PL is a straight line, which might not necessarily be true. But either way, if PL is a straight line, take a look at this. M is the midpoint, because M is the center of the circle, right? So the distance from P to L is equal to the distance from M to L, right? So we are going to use translation to find the coordinates of L. We don't have to use translation. We can find the equation of the line, right? Because we have P and M. We can find the equation of the line. But if we use the translation, take a look at this. So we have L, we have M, and we have P. So let's look at their coordinates, right? So the x coordinate of M is 1. The x coordinate of P is 3. So the difference in the x coordinates from M to P should be the same difference from L to M, because M is essentially the midpoint of PL, right? So if the x coordinate of M is 1 and that of P is 3, the difference is 2. That should be easy to see. The same should be true with regards to the distance from L to M. So here we must have minus 1, right? Because from -1 to 1 is 2 units. From 1 to 3 is 2 units. We can do the same about the y values. So the y value of P is 9. That of M is 3. We can see that the difference is 6. So what must be the y value of L? It must be -3. So this is L, -1 and -3. Obviously, you can use what do we call this? We can use the midpoint theorem also and find the coordinates of L. But anyway, stories. Let's take a look at 4.2. So 4.2, determine the equation of tangent ST to the circle at P. So we are interested in the tangent of ST. So the tangent ST rather. Let me just highlight that. So this is too thick, let's be a bit slim. So this is ST. This is ST. ST is that tangent. Obviously, we know that the tangent is perpendicular to the radius, right? And MP is clearly a radius. So we can say that the gradient of MP multiplied by the gradient of ST should give us -1. So the gradient of ST is equals to -1 divided by the gradient of MP, right? But then what is the gradient of MP? The gradient of MP, y2 minus y1 divided by x2 minus x1, right? So we're gonna have -1 divided by the gradient of MP. So let's take P as our second point. If we do that, y2 minus y1 is gonna be 9 minus 3, right? And then x2 minus x1 is gonna be 3 minus 1. So this is equals to -1 divided by 9 minus 3 is 6. 3 minus 1 is 2. So 6 divided by 2 is 3. So this is the gradient of ST. It is -1 over 3. The question says the tangent, actually, not the gradient, but we are a step closer. So we have y is equals to -1 over 3 x plus c. We just need to substitute a point on ST, which is P. So if we substitute P of coordinates 3 and 9, we're going to have 9 being equals to -1 over 3 x plus c. Well, x is 3 here because we're substituting P. So we have 3 plus c. 9 is equals to -1 plus c. 10 is equals to c. So y is equals to -1 over 3 x plus 10. We're good to go. Okay, so this is 4.2. Let's take a look at 4.3. So 4.3 says that show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 is equals to 0. Okay, I think this is we should be grateful that this is the equation that we found in the exam. Most people, if they're given this and they're supposed to write it in the other form, x minus a squared plus y minus b squared is equals to r squared, they are going to have issues compared to if you're given if you're given, what do we call this? If you're given the point and the center and you're supposed to write it in that way. But anyway, stories. We know fully well that the equation of the circle, well, I've already written that it is 4.3, can be given by x minus a squared plus y minus b squared is equals to r squared. So our center is M, right? 1 and 3. So we're going to have x minus 1 squared plus y minus 3 squared being equals to r squared. Do we have the radius? Okay, we don't have the radius at this point, but obviously we can find the radius. Yeah, let's just go ahead and, okay, let me just say r squared. Let me find the radius, right? So the radius, we can use MP. We can use MP because MP is the radius. And then this is y2 minus y1 squared plus x2 minus x1 squared. So we're going to have 9 minus 3 squared plus 3 minus 1 squared. Okay, so MP is equals to square root of 9 minus 3, that's 6, so we have 36 plus 4, right? So let's square MP. Let's square both sides because we are looking for the radius squared either way. So MP squared is equals to, this is 36, so MP squared is equals to 40. Okay, so we know that radius squared is 40, right? And then x minus 1 squared, that is x squared minus 2x plus 1. And then we have y minus 3 squared, that is going to be plus y squared minus 6y plus 9. Everything is equals to 40 because r squared is 40. So let's rewrite that in this form that we are supposed to. So we have x squared plus y squared, right? It is there, we're just putting them next to each other. And then minus 2x, it's easy to see how that comes about, minus 6y. And then plus 1 plus 9 is 10. And then 10 minus 40 is minus 30. So this is what we are supposed to show. And yeah, as you can see, we have that. And then now in 4.4, we are supposed to show that d is equals to 7. So d is the x coordinate of r, where the y coordinate is 1. So, right, we can substitute r into this equation in that form, or we can substitute r there. I think it's better if we substitute it here, right? So we have x minus 1 squared plus y minus 3 squared is equals to 40, right? X is what you're looking for, so we have d minus 1 squared plus y 1 minus 3 squared is equals to 40. So d minus 1 squared, 1 minus 3, that is minus 2, we square that, we get plus 4. So plus 4 is equals to 40. So d minus 1 squared is equals to 36. I can take square roots on both sides. D minus 1 is equals to, well, plus or minus, okay, d minus 1 is equals to 6. Let me not complicate things. D is equals to 7, right? We have showed that d is equals to 7. If you substitute r on the other equation, it is also fine. It is also fine. You don't have to ask me and say, if I substitute it in the other equation, is it also fine? Will I get all the marks? It is fine. As long as you're not lying. As long as everything is mathematically correct. So that is 4.4. Now let's take a look at 4.5. So 4.5, calculate the size of angle L. So we are looking for the size of this angle. We're looking for the size of this angle. Let me just put a dot there. But we found the coordinates of L by saying that PL should be a diameter, right? And then if PL is a diameter, this here should be 90 degrees. This here should be 90 degrees. If that is 90 degrees, and then we have L, not L, but ML, and then here we have MP. We will end up with equal angles, like opposite angles, not opposite angles, opposite angles opposite equal sides. That's what I'm looking for. We're going to end up with angles opposite equal sides. That's what we are going to end up with. We're going to end up with angles opposite equal sides. Okay, so we will end up with having angle R plus angle L plus angle P being equals to 180 degrees, because those are that's the sum of angles on a triangle. But angle P should be equals to angle R, not R but angle L rather, should be equals to angle L, right? So by saying that, we can then say angle R plus 2 angle L is 180 degrees. But we know that R is 90, so we have 2L being equals to 90, right? 180 minus 90. So angle L should be 45 degrees. That is 4.5. Okay. And then let's carry on. 4.6. TR is a tangent to the circle at R. So let's just, okay, this is TR. This is TR. It is a tangent to the circle at R. And then the question says prove that PT is perpendicular to RT. So I'm not gonna give myself a headache. I'm just gonna find the gradient of PT and find the gradient of RT and compare the two. We do have the gradient of PT because PT same as ST, right, is the same line. So let's just go up and see what that gradient is equal to. Minus 1 over 3. So the gradient of PT is equal to minus 1 over 3. This is from 4.82. Yeah, because PT and ST, coordinates of the same line. So we have that. Now we just need the gradient of RT. So how can we do that? Well, we can find the gradient of MR, because MR should be a radius there, and then that gradient should be perpendicular to that of RT. So the gradient of MR is equal to y2 minus y1 divided by x2 minus x1. What is y2? Let's take the coordinates of R. Y is 1, and then y2 is 1, y1 should be 3. And then the coordinates of D is 7, so we have 7 minus 1. So this is minus 2 divided by 6, which is equal to minus 1 over 3. So the gradient of MR multiplied by gradient of TR should be minus 1. So the gradient of TR is minus 1 divided by minus 1 over 3, which is equal to 3. So 3 multiplied by, this is the gradient of TR, multiplied by minus 1 over 3, the gradient of PT, gives us minus 1. So we have showed that these two lines are perpendicular to each other, as we can clearly see here. But in closing, let's go back to 4.5. I'm thinking about something here. Is it that easy? Do we just say L is equals to P? Do we just say L is equals to P? Do we do that? Or we have to actually show first that RL is equals to PT? Do we have to show first that RL is equals to PT? Well, if we have to show first, we have the coordinates of P, we have the coordinates of R, we have the coordinates of L. So we can find PR and find LR to convince ourselves that indeed PR is equal to LR. And then we can use angles opposite equal sides. There we go. Which video do you want me to do next? Let me know in the comments. Determine without using a calculator the value of cos A. So let's go ahead and take a look at what is happening. So we have a point P, which is what we usually have, right? And then on this point P, obviously we have the X and the Y. The X happens to be minus 3 and the Y value is minus 4. Why don't we find the hypotenuse? Why don't we find R from the get-go? So if we do that, R squared plus, well, not R squared plus, but R squared should be equals to X squared plus Y squared. So R squared will be equals to minus 3 squared plus minus 4 squared. It should be easy to see that R is actually equals to 5. So we have our X, our Y, and our hypotenuse. Minus 3, minus 4, and 5. Now let's go ahead and solve our equations. We are looking for cos of A. So cos of theta is equals to the adjacent over the hypotenuse, right? The adjacent is usually the X and the hypotenuse is R. So in this case of ours, we're going to have cos of A being equals to minus 3 over 5. Okay, and then 5.1.2, we have cos of 2A. This is very typical that 5.1.1 will be pretty much straightforward, and 5.1.2 we have these kind of trig ratios. We have cos of 2A It is very typical. But we just need to know that cos of 2a is equals to 1 we just need to recall that cos of 2a is equals to 2 cos of a squared. Cos of a squared, let me just rewrite that, cos of a squared minus 1. So do we have cos of a? We do. So we're going to have 2 cos of a is minus 3 over 5. We square that and subtract 1. So let me just put that in my calculator and not complicate my life. So 2 multiplied by minus 3 over 5 squared minus 1, that is minus 7 over 25. So we have minus 7 over 25. Okay, and then the question that follows, 5.1.3, we are determining the value of sine of a minus b if it is given that sine of b is equals to 4 over 5, where b lies between 90 and 360. Okay, so let's take a look. We know from the basics, right, that sine of a minus b is equals to something. So the best thing to do with this kind of questions is to not write the formula from your head. You have the question paper, copy it down. So in this case, we will have sine a cos b minus cos a sine b. Okay, so we have sine b, it is given to us, right, 4 over 5. And then what else do we have? We have sine b, and we have cos a. We have cos a from the question above. So we have sine b and cos a. So what is there to worry about? We need to find a way to find sine a and a way to find sine cos b. So let's think about that and see what happens. We are given that sine of b is equals to 4 over 5. Sine is equals to the opposite, which is y, over the hypotenuse, which is r, right? So we can find x using that. We can say that x squared plus y squared is equals to r squared. So x squared is equals to 5 squared minus 4 squared. So x squared is equals to 9. X is equals to plus or minus 3. So there we go. We have plus or minus 3. We have a decision to make. Is it plus 3 or minus 3? That's where these information comes in handy. So B range is running from 90. So from 90 somewhere here, right, to 360. Yeah, that's where B is running. So what is the okay, so let's just sketch. Let's just sketch, because I don't want to explain too many things without sketching, because it will become a bit troublesome. So we have our Cartesian plane there. We have y. Y is 4, right? So y is right here. We have 4. And then our x, that's what you're looking for. Is it plus 3 or minus 3? Okay. Our angle is between 90 and 360, right? So we can take x as minus 3. So there we go. We have x as minus 3, and then our r is going to be 5. Okay. So there we go. We can have that like that. So that will help us with sine A and cos B. So sine A is from the diagram we started with, right? So sine A should be opposite y over r. So sine A y, we said that it is minus 4, right? And r is 5. And then what about cos? Is it cos that we are worried about? Cos of b. Cos of b, it is gonna be x over r. So let's figure out what that is. X minus 3 r is 5. So there we go. We have sine a and cos of b. So sine a minus b is going to be equals to sine a, which is let me take a look. Sine a sine a is y over r, right? So minus 4 over 5. And then cos b is minus 3 over 5. Then we have minus cos a. Cos a, we calculated it in 5.1.1. It is, let's see, let's see, minus 3 over 5. So we have minus 3 over 5. And then what about sine b? Sine b, cos, that is cos a. What about sine b? Do we have sine b? Yeah, sine b is 4 over 5. So we have 4 over 5. Okay, so let's take a look. Let me just put that in my calculator and not complicate my life. Minus 4 over 5 minus 3 over 5 minus 3 over 5 multiplied by 4 over 5. I get 24 over 25. So yes, that's what we end up with there. And then 5.2, yeah, 5.2 is quite a beautiful question. 5.2 is quite a beautiful question. Let me show you why I say that. So if cos of alpha is equals to p, express the following in terms of p. Yeah, we have that expression there, right? But let me just show you something. Let's slow down a bit. Okay, we know that sine of 2x is equals to 2 sine of x cos of x. So from this, it should be easy to see that sine of x cos of x is equals to sine of 2x over 2. So I want us to apply this idea here, right? Because here we have cos of what is inside the brackets here, and then we have sine of what is inside the bracket over 2, right? So sine of x cos of x is equals to sine of 2x over 2. So we want to use this in order to answer this question. So in our case, sine of 2x in our case, so we have sine of, in our case, we have, let me open a bra first. Okay, we have sine of 2, right? And then x is alpha over 2 minus 45. This is what we have in our case. Everything divided by 2, right? And then this is equals to sine of 2 and 2. I will cancel out, right? We're gonna be left with alpha minus 90. Everything over 2, right? So we can substitute this back here, right? Because this thing is equals to sine of x cos of x, right? So we will say that on the numerator here, we're gonna have sine of alpha minus 90 over 2, right? These two, and then everything divided by, let me write that again, everything divided by 2, these two, right? So this is going to be equals to sine of alpha minus 90 over 4, right? So what is sine of alpha minus 90? Sine of alpha minus 90 is equals to minus cos of alpha over 4. So this is where 5.2 ends up. It's the last question, 7.4, that I'm really interested in, and you'll see why. Let's go through 7.1 first. So the question Write down the equation of the asymptote of f in the interval 0 to 180. Like I said, when we're doing paper 1, most people, they know the answers to this kind of equation. But the problem is the interval. They forget to only look at the interval. So we wanted the equation of the asymptote of f in the interval x runs from 0 to 180. Let me show you what happens here. So we have to focus on only this interval. If you look at everything else, anything else, it is wrong. You need to focus on only this interval. Let me show you what I mean by that. So we can see that between 0 and 80, we have a asymptote at x is equals to 90. So the answer to 7.1, x is equals to 90. You might think it's not a big deal, but I can assure you there's somebody else who took minus 90, right? They forget to only focus on the interval that is given. But anyway, stories. Let's take a look at 7.2. So 7.2, write down the values of x in the interval. Again, we have an interval which we need to pay attention to, minus 180 to 0. So minus 180 to 0, where f of x is less than 0. It's less or equals to, rather. Right. So we are looking for where f of x is 0 or negative, essentially, in that interval. So let's take a look. From minus 180 to 90 degrees, we can see that it is greater than 0, right? Well, at minus 180 is equals to, is it defined at minus 180? That's another question we should ask ourselves. Is it defined at minus 180? At minus 180, okay, it is defined. So we don't have an issue there at minus 180. So minus 180 should be part of our solution. Why do I say it should be part of our solution? Because you're looking for parts where f of x is less or equals to 0 in this interval. And that interval includes minus 180. So already we can see that x, oh well, let me change the color there. Already we can see that x is equals to 180 degrees, because when x is equals to 180 degrees, tan of 180 is 0. So that should be minus 180. I think the effect should be the same, really. Yes, it is the same. Tan of 180 is equals to tan of minus 180. So that is part of our solution. But then from minus 180 to, I don't want to say to 90, but to very close to minus 90, we can see that it is greater than 0. So we are not looking for that. That is not part of our solution. But when we go from minus 90 to 0, you can see that it is less than 0. So that should be part of our solution. X is also an element of, do we include minus 90? We don't. Why don't we include minus 90? Because it is not defined. But do we include 0? Let's see. Tan of 0 is equals to 0. It is defined there. So let's include 0 because it is defined at 0. So this is the values of x for which f of x is less or equals to 0. There we go. Okay. So that is 7.2. Let's take a look at 7.3. 7.3.1. Okay, let's take a look and see what is happening. We're given that g of x is equals to cos of 2x plus 1. The question says write down the period of g. So obviously the period is going to be equals to 360 over 2. Where are we getting the 2? Right here, right? Where it says cos of 2x. Yeah, we divide 360 by that 2. And then the period is going to be 180 degrees. So we have the period. And 7.3.2 on the grid given in the answer book, draw the graph of g of x is equals to cos of 2x plus 1 for the interval and clearly show the intercepts with the axis as well as the coordinates of the turning points. Okay, so I don't have the grid obviously, so I'm just going to use this Cartesian plane that is already in front of us here. So let's see how we can use that in order to actually answer this question. So which interval do I want to use? Let me use an interval of 30. Let me use an interval of 30. So from minus 180, I'm going to have minus 150. I'm going to have minus 120, minus 90, minus 60, minus 30, 30, 60, 90, 120, 150. What's the interval again? Minus 180 to 180. So I need all those points. I need to substitute those points into, I need to put that in my calculator and find the corresponding y values. Okay, so cos of 2 multiplied by what? 120 minus 120, everything plus 1. So I'm getting a half. So we have a coordinate here. Oh, not the event. I shall start with minus 180 and not minus 120. What am I doing? So here we get 2, right? So somewhere here we have our first point. And then let me substitute minus 150. 3 over 2, which is 1.5. So somewhere here. I want these dots to be straight. And then let me substitute minus 120. I get a half. So there we go. And then when I substitute 0, oh no, minus 90. Why do I want to substitute 0? Minus 90, I get 0. And then minus 60, I get a half. So there, minus 30, I am getting 1.5. So we are somewhere there. And then 0, I'm expecting 2. Yes, we have 2. I think we can already see the trend. We can already see what is happening here. And then from there, I want to substitute 30. I get 1.5. When I substitute 60, I get half. When I substitute 90, I get 0, right? These points are important because I need to show all the intercepts. Okay, and then when I substitute 120, I get half again, 150, that is 1.5, and then lastly 180, I get 2. 180, I get 2. So let me join these points. Let me just use a faint, well lined. Let's see. I want to join these points. So you should have something like this. You should have something like this. We can clearly see that the period is 180 here because we have 2 cycles over 360. So that is 7.3.2. Now let's do 7.4. Right, the beautiful question. Clearly show the intercepts with the axis. So you will provide the intercepts there. We can see the intercept. We have 2 minus 90. We have 90. So you will show that there in coordinate form. Yeah, but that is essentially what we need to have. Use the graphs to determine the general solution of 2 cos of cos to the 3x rather minus sine of x is equals to 0. So when I looked at these, I sort of knew that well, the question says use the graphs, but you know, even if the question didn't say use the graphs, I would know that I'm supposed to use the graphs somehow. But we don't have the graph of cos of x to the power 3, and you know, so how do we then use the graph to answer this, which looks unrelated to the graphs? Let me show you. So first thing, 2 cos of x to the 3 is equals to sine of x, right? So it became pretty much, straightforward that if I divide both sides by cos of x here, then at least I'm gonna have the graph of tan of x. As you can clearly see, I have tan of x there. So that is tan of x. It's one of the graphs that I have. So I don't want to mingle with it. I don't want to interfere with that. I want to leave that as it is. So how do I then work on these so that it can be equals to my other graph, which is cos of 2x plus 1? I'm like, oh, okay, you know what? Let me take my question paper. Let me go to the back and look at those identities and see if I can come up with something. And then I realized that cos of 2x, right, is equals to 2 cos of squared x minus 1. So take a look at what we have. We have 2 cos of x squared. So clearly 2 cos of x squared is equals to cos of 2x plus 1. And this right here is the graph that we have, right? So we can say but cos of 2x plus 1 is equals to tan of x. So in order to find the general solution using the graphs, we just go into our graphs and looking for values of x for which the two graphs are equal to each other, right? So if we go there, we can see clearly here that we have they are equal to each other at that point there, okay? And then where else are they equal to each other? They are equal to each other at that point. They're equal to each other at that point. Do we have any other point where they are equal to each other? It seems like those are the only points that they're equal to each other. So we need to read off those points. Those points, they look like they are between minus 150 and minus 120, right? So I can just test that. I can say tan of between 150 and 125. So 150 plus 120 rather. That is 270. We divide that by 2. We get 135. Okay, I get minus 135 as the number between minus 150 and minus 120. So let me just substitute it into these two graphs, these two functions, and see what I get. When I substitute minus 135 here, I get 1. So let me substitute it here. 2 minus 135, well, minus 135. I also get 1 here. So x is equals to minus 135 degrees. It's one of the solutions, right? And then here we have 30 and 60. So I'm thinking already I'm thinking that the point in between is 45. So tan of 45, it's 1. And then cos of 2 multiplied by 45 plus 1 is also 1. So x can also be equals to 45 degrees. Calculate the length of AC, the distance between the observer at A and the foot of the building. So let's go ahead and take a look and see what is happening. So in the diagram, C is the foot of a vertical building. So yes, C, right? The foot of the vertical building. And D is the top of the same building. And there we go, our haunted house. And then the height of the building CD is 16 meters. We can clearly see it is shown here, 16 meters. Let me change that a bit. So we have 16 meters. Still not really visible. Maybe I should use the red. Let me give it a try. Or let me just write it on this side. So that is 16 meters. And then the two observers are standing 19 meters apart at points A and B. So we have an observer at A and another one at B. They are 19 meters apart. A and B are where A, B, and C lie on the same horizontal plane. Okay, a painter, right, is working at point E, somewhere here, right? And then on the building, the angle of elevation of D from A is 46.85, we can clearly see that on our sketch. And then DEB is 122, here it is, and BCA is 105.61. So let's go. We're looking for the length of AC. We can see here that we have a right angle, the triangle, right? We are looking for the length of AC. The first thing that I think about is trig ratios, because I have a right angle, the triangle. So I have the opposite, which is 16 meters, right? Opposite to the angle A here. And I'm looking for the adjacent. So which trig ratio do I use in this case? Well, tan of theta is equals to y over x. Tan of theta gives us the gradient. So it is y over x. In this case, we're going to have tan of 46.85 being equals to 16 over AC. So AC is equals to 16 over tan of 46.85. So now I just need to put that in my calculator. 16 over 46.85, and then that is 14.9987. I think I can round that off to 2 decimal places and write it as 15 meters. That is 8.1. What about 8.2? Let's hear the stories. Calculate how far the painter at E is from the top of the building. Okay, so like I've always said, it's better to start from a triangle with a lot of information and move towards the triangle without. So let's see how that plays out. In this question. We know that AC is 15, right? So we have 15. We have 16 in place of CD. So and then AB is said to be 19. AB is said to be 19. And then we have the angle C here. We have the angle C. So how can we move from AC to finding C? Well, E, right? Or at least CE. Because if we have CE, we can just say 16 minus CE. So how can we do that? How can we move in that fashion? Right. So we have the length of AC, which is 15. We have AB, which is 19. And we are given this angle, right? 105.61. If we apply the sine rule on this triangle, we can say angle C over sine of angle C over the opposite side, and then we can say 50, no, not 15, but sine of B over the opposite side, which is AC. And then if we do that, we're gonna have the size of angle B. But why do we want the size of angle B? Why do you want the size of angle B? Well, if we have angle B, let's say we do manage to calculate the size of angle B, then we're going to be able to find the size of this angle here, angle A, right? And then why is it important for us to find the size of angle A? If we find angle A, then we can use the sine rule once more to find the length of BC. Okay, if we have the length of BC, what can we do? Okay, we have BC, and then we have this angle here, right? Because we have that other one which is at the top, and that's a straight line. So we have 122, so the one at the bottom, it should be 180 minus 122, which is 58. So we are going to have BC. We're going to have the angle there at the top. This is 90. So we can also find this angle. I think using trig ratios, we should be able to find CE. Okay. So let's go ahead and put all of that in motion. So we are saying we want to start by finding the size of angle B. Okay. So we're going to say sine of C, angle C, right, divided by AB is equals to sine of B divided by AC. So here we have sine of 105.61 divided by AB, which is 19, being equals to sine of B. So this is what we want to find. divided by AC, which is 15 units, right? So sine of B is equals to, so this is 15. I have 15 multiplied by sine of 105.61 divided by 19. Yes, and then I'm getting sine of B being equals to 0.7604. So B is equals to, let me take sine inverse here. When I do that, I get angle B being equals to 49.4955. So this is the size of angle B. This is the size of angle C. So we should be able to find the size of angle A. So angle A is going to be 180 minus 105.61 minus 49.4955. So allow me to put that in my calculator. 180 minus 105.61 minus 49.4955. I'm getting 24.8945. So 24.8945. So now we will use angle A to find CB, right? So we're gonna say sine of A over CB is equals to sine of, yeah, now we have the freedom of choice, C over AB. So CB is going to be equals to sine of A multiplied by AB divided by sine of angle C. So let me put that in my calculator. Sine of A is 24.8955 multiplied by AB is 19 divided by sine of C is 105.61. So CB is equals to 8.3. So this is 8.3 meters. So we have CB, which is 8.3 meters. Let me just erase some of these things. So CB 8.3. So this is 8.3. So I can use trig ratios here. Which trig ratio though? To have the size of angle B. Oh, okay. Not yet. I don't have the size of angle B as of yet. But obviously I can also use this angle 58 degrees. Yeah. So this 8.3, if I use 58, is going to be my opposite, right? So I'm looking for the adjacent. So tan of 58 is equals to 8.3 divided by CE. So CE is equals to 8.3 divided by tan of 58, 5.1864. So from C to E is 5.1864. So how far is E from D? Well, 16 minus the answer. It is 10.81 meters apart. What is the question? Yeah, it is, how far is it? It is 10.81 meters far from point D. Calculate with reason the value of A1. So let's take a look and see what is happening here. So the first thing that we must do in Euclidean geometry is to write down the keywords, because that's what's going to help us to actually answer all the questions that we will come across. So in the diagram, ABCD is a cyclic quad. So already we have the first keyword there, cyclic quad. Right, let's carry on. BC is produced to E, AC is drawn, and we are told that A1 is equals to half of B. So A1 is equals to half of B, right? And then A2 is equals to 46, C is equals to 86. So let's see how we can use these two keywords to answer these two questions that we find in front of us. So 9.1, we are looking for the value of A1. The first keyword is cyclic quad. So let's see how we can use the cyclic quad to find A1. So A, B, C, D is a cyclic quad. Immediately, I'm realizing that C1 is an exterior angle of that cyclic quad, and it should be equals to A2 plus A1, right? So C1 should be equals to A2 plus A1. We're supposed to give a reason. The reason is that an exterior angle of a cyclic quad is equals to the interior opposite. So 86 is equals to 46 plus A1. A1 is equals to 40 degrees. Okay, there we go. That is the size of angle A1. Okay, let's carry on and do 9.2. So 9.2, hence prove that AD is equals to DC. AD is equals to DC. So let's go ahead and take a look at AD and DC. They're said to be equals to, we're supposed to prove that they're equals to each other, right? If they're equals to each other, we must have angles opposite equal size. So C2 must also be 40 degrees, right? If they are indeed equals to each other. So if we prove that C2 is 40 degrees, then we have proved that AD is equals to DC. So how can we do that? Back to our keywords. The first keyword is cyclic quad. So let's see how we can use that. So C2. Well, we know that A1 plus A2. A1 plus A2. If we add A1 plus A2 and C2 plus C3, we should get 180 degrees because they're opposite angles of a cyclic quad. But I can see that C1 is 86. So because C1 is 86, I can find the sum of C2 plus C3 using the sum of angles on a straight line. So C2 plus C3 is equals to 180 minus 86. So 180 minus 86, that is 94 degrees. So C2 plus C3 is 94 degrees. Okay. And then what else do we have? We have C2 plus C3, which are equals to 94 degrees. And then A1 plus A2 are equals to 86 degrees. Yeah, so clearly when we add these two, they will give us 180. But we still need to find the actual value of C2. We still need to prove that C2 is 40 degrees. So how can we go about that? Well, we've tried to use the first keyword. Let's try and use the second keyword and see what happens. So we know that A1 is half angle B. So A1 is 40 degrees, right? So angle B should be 80 degrees because A1 is half angle B. So here we have 80 degrees. Okay, so how can we use that therefore? Well, we have A2, which is 46. We have B, which is 80. So we should be able to find C3, right? Using the sum of angles on a triangle. So C3 is equals to 180 minus 80 minus 46. So 180 minus 80 minus 46 is equals to 54. So C3 is equals to 54. So C2 should be equals to 94, right? Minus 54, which is 40 degrees. So we have shown that C2 is equals to 40. So we can say that AD is equals to DC. C2 is equals to A1. Angles opposite equal size. Yeah, we're sort of reaching there in reverse. So that is question 9. Quite a easy question to do, really. Shouldn't take too much time. Prove with reasons that OR is to WS is equals to 1 is to 2. So let's go ahead and take a look at our question statement and see which keywords we can extract. In the diagram, O is the center of the circle. easy to see. Triangle PWS, so here's P, we have W, and S is drawn with PW and S on the circle. OR is perpendicular to PS. There's an angle of 90 degrees there, so that is also easy to see. PRS is produced to T. SW and OT intersected V. And then you are told that OV is to OT is equals to 1:4. The first question, back to the first question, prove with the reasons that OR is to WS is equals to 1:2. Okay, we don't have much to work with as far as the keywords in the question are concerned. But let's take a look at our sketch. Maybe there's something we can cook there. So first of all, PWS is a triangle, right? So PW must be a straight line. Yeah, here we have PW. This must be a straight line. Yeah, since PWS is a triangle. If PW is a straight line, then PW should be a diameter, right? That should be easy to see. And in saying that PW is a diameter, then we are saying that angle S is 90 degrees, right? But now look at this. Angle S is 90 degrees. Angle R is also 90 degrees. So WS should be parallel to OR, right? Now let's take a look at the question we actually have in hand. We want to find the ratio of OR. So here's OR and WS. Okay, but if you take a look at OR, we can say that OR is a base, right, or a side on triangle PRO, and then WS is a side on triangle PWS, right? But these two triangles are similar to each other. Why? R is equals to S. They are both equals to 90. We have talked about why angle S is equals to 90. Angle S is equals to 90 because it's been subtended by diameter SW. Okay, but in triangle POR, well, triangle POR and PWS, they share this angle right here. They share that angle P, right? So angle P is equals to angle P, right? It is a common angle. So in saying that the third angle of the two triangles should be close to each other. So now we have the privilege to can say that the triangle POR is similar to triangle PWS, angle. Right, so now that we've proved that the two triangles are similar, we can play around with proportions because we have proved that the two triangles are similar. But I want you to realize something. OP is a radius. This is a radius right here. And then OW is a radius, right? So PO divided by OW should be 1/1 because it's a radius. So there we go. PO divided by OW is equals to 1/1. So we can see that no issue whatsoever. But then let's look at the two triangles that we have. On triangle POR, we have a side PO, right? We have a side PO. And then on triangle PWS, we have a side PW. But what is PW? PW is 2R, is 2 radiuses, right? So PO divided by PW should be equals to R divided by 2R, which is equals to 1/2. So this is PO divided by PW, right? But we are interested in OR and WS. But OR is this side on the smaller triangle, and WS is this side on the bigger triangle. So we can also use that those sides, they should also be in proportion. So we can say that PO over PW is equals to OR over WS. So OR over WS. The reason here, right, I'm forgetting to give the reason. The reason is that POR is similar to PWS. That is the reason there. So OR over WS is 1 over 2. So OR is to WS is equals to 1 is to 2. Okay, that is 10.2.1. Let's take a look at 10.2.2. Calculate the length of PT. What is PT? If ST is equals to 15 units. What was I writing there? So ST is 15 units. Okay, so let me erase some things here so that I can have a bit of clarity. What are we saying? Let's see. So calculate the length of PT. This is PT. PT is this entire line. And then ST is 15 units. So this is 15 units. Okay. In our question here, we are given that OV. Well, I hate this is two thing. Let me just say OV over OT. This is two thing. It annoys me. So OV over OT is equals to 1 over 4. This OV is true. I don't like it at all. Okay. So let's see what we can cook there. This is like we've showed parallel to this. Yeah, that is important. We need that there. And then OV, where is OV? OV is this side, right? So the ratio is 1 over 4. So if this is X, then OT should be 4X, right? Meaning that here, let me write it like this. Yeah, this is X. Here we should have 3X. So that OT can be 4X. That's what we know. But OR and VS are parallel. So this should also be X. And then this should be 3X. Do you see that? Do you see that? Okay, so let's get formal. OV over, I don't want to say OT. I want to say VT is equals to RS over ST. So OV over VT, that is going to be X over 3X. RS, we don't know that one. And then ST is 15, right? So this is 1 over 3 being equals to RS over 15. So 3 RS is equals to 15. RS is equals to 5. Okay, so here we have 5. ST is 50. So now we just need to find PR. We need to find the length of PR. Okay, but we know that from O to P is equals to the distance from O to W. So from R to S should be equals to the distance from R to P. So we also have 5 here. So PT is equals to 15 plus 5 plus 5, which is equals to 25. There we go. Question 10.